Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. This video lesson we are going to look at interpolation for our numerical computation. Now, interpolation is going to be a very useful way to evaluate data, say, from a table, or maybe we have experimental results that we want to use. The most common type is linear interpolation. And probably when you've taken your thermodynamics course and learned to read steam tables, you learned to do this. The idea is based on similar triangles. So if you have two data points that you know, x1 and x2, and you're trying to estimate what x is for some value near there, then you can draw a set of triangles. And using the concepts of similar triangles, we can say that the slope of this line has to be the same for all points. And if you use this, we can use this to estimate f of x, being our unknown. And this formula here shows that. So basically it's taking the slope from our unknown point to point x1 and the slope of our point between the two known points x1 and x2. But we also can do what's called a Lagrange interpolation polynomial. Now, if you think of fitting two lines to a point, one way to do this is through this formula here, and with a little bit of algebra, you'll see that it is exactly the same formula as we just had. You'll have to get a common denominator for that. And the idea is that if you have two fixed points, and I know the value of those 2 points, f of x naught and f of x1, then I can use that to figure out f of x. But I could also go to a quadratic equation, and if I want to fit 3 points to a quadratic equation, then this would be a similar equation. And in fact, we can extend this concept up to n points. Now, if I have an nth order polynomial through n points, it will exactly go through those points. However, it probably is going to be a little bit more wiggly than what nature actually would be predicting. And so we don't often do this. However, we can find that using a second order or third order fit to 3-4 points actually can improve our interpolation, our ability to predict a point in between these points. And then our other method is going to be just to simply use these linear regression curve fits that we worked on in the previous lessons. And we can use this best curve fit as a prediction tool. And this should definitely be smoother than an nth order polynomial would be. But you're going to need to look at the graph of our curve fit and compare it to the graph of your data to determine whether or not it really is a good fit for all data points. But in general, this does tend to be an excellent choice. So how do you know which one you should use? Well, there's all sorts of rules for this. Frequently, we have some very high quality data. This would be things that we've done lots of repetition. This is published data such as steam tables, that sort of information, where we believe this data to be correct to high precision. And if it's nearly linear, then linear interpolation works very well as long as you're using the two nearest points. So typically values of u, h, v, and s that you might read from a steam table, as long as you're not near the critical point, linear interpolation works very well. Now, when it becomes nonlinear, then actually that second order Lagrange polynomial using the 3 nearest points can be very good. So this works for that steam table data that when it starts getting near the critical point. Or also vapor pressure data works very well with this. I am going to mention just briefly here, you can also do something called logarithmic interpolation, which is linear interpolation using a logarithmic form. So you would replace your f of x's with the natural log of f of x in our linear interpolation. You are not responsible for that in this course, but just know that that also is frequently done, especially for vapor pressure data. But now then, what about when you have that lower quality data? So maybe it's based on a single experiment, or an experiment that we've done in this class, okay, where we're using low quality instrumentation. In that case, the data is going to need to be smoothed. And so using the linear regression curve fit is probably your best opportunity to get good results for this. So in our next video lesson, we're going to be looking at an example using the Excel tools that we have available. Thank you very much for your time.